This presentation has been developed by Project 90 by 2030, conducting the piloting project funded by the British High Commission. South Africa's National Climate Change Response White Paper was adopted by Cabinet in October 2011, following extensive stakeholder comments submitted to a Green Paper published 2 years earlier. South Africa signed on to the United Nations Framework Convention on Climate Change, or UNFCCC, in 1995, and to the Kyoto Protocol in 1997. The Kyoto Protocol was ratified at the national level in 2001. Much of the legislation required for implementing the National Climate Change Response White Paper is contained in the 1998 National Environmental Management Act, or NEMA, and the subsequent Air Quality Act, which provides the regulations requiring mandatory reporting of greenhouse gas emissions. In 2008, Cabinet approved a long-term mitigation scenarios research report which informed the Copenhagen Commitment, the pledge that South Africa made under the UNFCCC in 2009. In 2011, as well as adopting the White Paper, South Africa hosted the 17th Conference of the Parties to the Framework Convention in Durban, and in terms of agreements there, we are expected to table intended nationally determined contributions at the end of March or in September, preparatory to COP21 in Paris at the end of 2015. The latest report of the Intergovernmental Panel on Climate Change has confirmed that the global goal of keeping global warming within 2 degrees is still within reach with a reasonable degree of likelihood. In other words, the measures exist to achieve the substantial emission reductions required to limit warming to 2 degrees. However, delaying mitigation will substantially increase the challenges associated with this goal, and implementing the reductions required do pose significant technological, social and institutional challenges. The IPCC report also found that greenhouse gas emissions have accelerated in growth this century. So while the rate of emissions growth in the last 3 decades of the 20th century was on average about 1.3% per annum, that rate has increased to 2.2% for the first decade of the 21st century. As the rate of global warming is determined by the concentration of greenhouse gas emissions in the atmosphere, we can work out what a risk-averse carbon budget would be for coming decades. In other words, the limit we should place on total greenhouse gas emissions into the future to have a reasonable chance of limiting global warming to no more than 2 degrees. However, the greenhouse gas emissions from burning fossil fuel reserves would be considerably greater than that carbon budget. Indeed, the assets listed on stock exchanges that assume the burning of fossil fuels already amount to some 3 to 5 times a reasonable carbon budget, as indicated, for example, in a report by the Carbon Tracker Initiative of 2012. Recognizing the risks of climate change and the challenges of a long-term phase-out of fossil fuel use, as well as the opportunities of climate change response, South Africa's policy seeks to be transformational. It recognizes job creation opportunities in climate change response on both mitigation and adaptation fronts, and the need for a major shift towards sustainable consumption and production patterns to decouple economic growth and development from negative impacts on environment and society. As reflected in the table of contents of the white paper, it is quite comprehensive in considering climate change response including the socio-economic impacts of such response. But this presentation will only be looking at the mitigation aspect, as that is what is addressed through the calculator. Consistent with South Africa's commitment in Copenhagen, the White Paper sets out a range for future emissions known as the Peak, Plateau and Decline, or PPD range. The White Paper provides specific numbers for specific years to characterize this range, and subsequent policy elaboration has provided this graphic of PPD against which one can calculate the cumulative emissions anticipated with the high, mid or low parts of that range. The Department of Environmental Affairs has indicated that the mid-PPD will be used as the basis for defining desired emission reduction outcomes in the short, medium and long term. A key feature of South Africa's policy is the adoption of a carbon budget approach, which considers the cumulative emissions from particular activities or economic sectors over time. A carbon budgeting approach involves a top-down perspective that looks at emissions across the economy and how the distribution of those emissions might change over time. It also allows for a developmental approach, as one can consider the optimal apportionment of a carbon budget according to the sectors or activities that add the greatest value to society as a whole. The calculator is not a carbon budgeting tool. It's not designed as a planning tool, but it can certainly help us to understand the context within which South Africa is developing desired emission reduction outcomes and will be apportioning available carbon space or acceptable emissions across different parts of the economy. The PPD range is shown in the 2050 pathway calculator as a green band, seen here superimposed on a projection of emissions to 2050, which is a pathway that might be expected without strong climate change response or a business-as-usual pathway. In these graphs, greenhouse gas emissions are projected in units of carbon dioxide equivalent, which is a unit that allows for reporting all of the greenhouse gases covered under the Framework Convention in a single unit based on their equivalence in terms of global warming impact with carbon dioxide. This graphic shows the South African energy system from supply on the left with primary energy inputs through transformation, such as electricity generation from coal or the production of petrol and diesel from oil, through transport in the energy carrier supply system and through to end use. It graphically demonstrates the dominance of coal in South Africa's energy supply mix, constituting 3/4 of primary energy supply. Energy policy and legislation require integrated energy planning to determine the best way to meet current and future energy service needs in the most efficient and socially beneficial manner, and a draft IEP report was published in 2013 and should be followed in early 2015 by a final integrated energy planning report that should indicate how energy planning will conform with the National Climate Change Response Policy. South Africa's emissions are reported in a national inventory, the system for which has recently been updated and subject to considerable improvement. The most recent version was published in November 2014 and reports emissions for the years 2000 to 2010. Energy supply and use accounts for 83% of South Africa's emissions, as can be seen here, along with emissions from industrial processes and product use, agriculture, forestry and other land use, and emissions from waste. Looking just at energy-related emissions, the top bar shows fugitive emissions, which includes methane leakage from coal mining and in gas supply. The green bar is transport emissions from the combustion of petrol and diesel, and the large blue bar, emissions from electricity generation, which makes up about half of South Africa's national emissions. The units here, given as gigagrams, are the same as kilotons of CO2 equivalent, so 400,000 gigagrams is 400,000 kilotons is 400 megatons. This table presents total annual emissions for the 10-year period broken down according to source. The right-hand column shows net annual emissions, that is, having taken account of a return of carbon to the soil through forestry and other land use. Second from right is the total emissions before accounting for this extraction by sinks. Thus, the total emissions in 2010 are 518,000 gigagrams or 518 megatons. However, absolute values and annual figures are not the focus of the calculator, which is on pathways and how we halt the growth of our emissions and then start to bring them down, as provided for in the National Climate Change Response White Paper and stipulated in the PPD range. While the overall shape of our future emissions trajectory is the main focus of the calculator, using this elaboration of the PPD range, one can calculate cumulative totals for the high, mid, and low PPD as follows. 23,000 megatons, giving us about 23 gigatons at the high PPD level, and at the lower end of the range a total of 14,830 megatons, or about 15 gigatons cumulative emissions. The mid PPD is given as the basis for deciding our future emission reduction objectives. One can redraw the PPD range with all lines starting at emissions as reported in 2010 and in a hypothetical projection using the cumulative totals still have three pathways ending within the range specified for 2050. Since the high trajectory cannot be reconciled with a fair national contribution to the global goal, we could look at just the mid and low projections, and the area under the graph is often referred to as a carbon budget, being the cumulative emissions over the entire period. So with mid PPD and a curve to achieve the same cumulative total, we have the red line, and what is below the low line is then a subset of that total. Targets for mitigation potential are most commonly given in terms of absolute emissions in a particular year. In this graph we see that our emissions would still be at 212 megatons in 2050, which would be equivalent to 3 tons per person with a population of about 70 million people. Given that global per capita emissions need to be less than 1 ton per person per annum in 2050, this would seem to be unnecessarily high. Per capita emissions refers to the total emissions divided by the number of people rather than an individual carbon footprint. If we release the end of the low trajectory from the PPD range figure for 2050, we can see a smoother reduction is possible, delivering a pathway that puts national emissions below 100 megatons in 2050, and this line would give us approximately 1.3 tons per person per annum for South Africans. A key feature of South Africa's policy is the adoption of a carbon budget approach, which considers the cumulative emissions from particular activities or economic sectors over time. A carbon budgeting approach involves a top-down perspective that looks at emissions across the economy and how the distribution of those emissions might change over time. It also allows for a developmental approach, as one can consider the optimal apportionment of a carbon budget according to the sectors or activities that add the greatest value to society as a whole. The calculator is not a carbon budgeting tool, it's not designed as a planning tool, but it can certainly help us to understand the context within which South Africa is developing desired emission reduction outcomes and will be apportioning available carbon space or acceptable emissions across different parts of the economy. Here, the three illustrative projections starting from emissions as reported in 2010 are shown to the left of the reference case projection used in the pathway calculator. The most recent assessment of mitigation opportunities in South Africa is contained in the November 2014 report Mitigation Potential Analysis. Previously, the long-term mitigation scenarios process took a fairly top-down approach, while the mitigation potential analysis takes a bottom-up approach starting from reported activities and emissions, and the projection of business as usual in the MPA is broadly consistent with the LTMS. Here, the baseline projection of emissions used in the mitigation potential analysis is shown with a sectoral breakdown from 2000 to 2050. This is known as the with existing measures projection because it takes some interventions post-2000 into account, but does not assume implementation of the white paper, as the MPA is produced to explore the best means for implementing the white paper. Here, the full extent of mitigation potential that was identified for analysis is shown superimposed on the base case projection from 2010 to 2050, such that implementing all of the identified measures brings emissions down to 740 megatons in 2050. The MPA process was not tasked with identifying how much mitigation potential might be possible over the entire period, but rather with providing some detailed analysis, including of socioeconomic impacts, on a well-defined set of mitigation actions. Thus, the electricity supply mix post-2030 was kept constant. It was locked in at the supply mix as provided for in the Integrated Resource Plan 2010, the prevailing plan for the electricity supply industry. And thus, only 43% of projected emissions from the electricity sector are mitigated in the MPA analysis by 2050. The MPA considers various criteria for the prioritization of mitigation actions, so not just according to least cost, but looks at packages of actions that could be prioritized for their social outcomes. Thus, while only implementing 100% of the identified measures puts us into the PPD range up until 2030, there was also consideration of subsets of the measures to see what the different impacts would be when measures are chosen according to different criteria. The MPA considers various criteria for the prioritization of mitigation actions, so not just according to least cost, but looks at packages of actions that could be prioritized for their social outcomes. Thus, while only implementing 100% of the identified measures puts us into the PPD range up until 2030, there was also consideration of subsets of the measures to see what the different impacts would be when measures are chosen according to different criteria. Like the MPA, the reference or base case projections in the calculator are driven primarily by desired economic growth. However, in the calculator, being more recent, the projections are slightly lower as the desired GDP growth has not yet materialized. The scope of mitigation actions that can be modeled with the pathway calculator is considerably greater than the mitigation potential analyzed within the MPA, and the calculator allows for full decarbonisation of the electricity supply industry, as indicated in the graphs to the right, showing emissions just from electricity supply. The relatively modest mitigation assumed in the electricity supply industry in the mitigation potential analysis allowed for detailed analysis of mitigation actions aimed at reducing electricity consumption, such as energy efficiency. But in fact, considerably more potential is available, as demonstrated in an update to the IRP 2010 published by the Department of Energy in late 2013. The update report includes scenarios for emissions decline through to 2050, including an advanced decline scenario that brings electricity emissions down to 140 megatons in 2050. The pathway calculator allows us to look at real decarbonisation trajectories for the electricity supply industry, such as superimposed on the update report here, a strong decarbonisation trajectory to 2050. The Carbon Tracker report for South Africa highlights why we should be looking at such a trajectory for electricity supply and phasing out coal-fired electricity generation. The bar on the left of this graph shows the carbon contained in South Africa's coal reserves and resources. In other words, burning all of our identified reserves and resources would release over 40 gigatons of carbon dioxide equivalent, while coal reserves already listed on South Africa's stock exchange would be responsible for 17.7 gigatons of emissions. While the focus of Carbon Tracker is on the risks of stranded assets or a carbon bubble, it highlights why we should start to address our heavy dependence on coal. The reference or base case in the 2050 calculator is not proposed as a credible future scenario, but rather a business-as-usual projection against which to consider mitigation pathways.